We start with the ideal filter, the sinc function, which is infinitely long. To make it causal and to obtain a desired trade-off between the transition band width and the stop band attenuation, we multiply it with a finite length window. This window is either obtained by optimization or is chosen from one of the well-known and studied windows like we've seen in the previous tutorial. Longer filters also lead to narrower transition bands. The resulting frequency response after multiplying the ideal impulse response, the sinc function, with the window function is then the convolution of the ideal frequency response and the window frequency response. The resulting passband width is the ideal passband width plus the passband width of the window, and the resulting stop band starts at the stop band frequency of the ideal frequency response, the cutoff frequency, plus the frequency of the start of the stop band of the window function, adding the transition band. To obtain a given passband or stop band, this has to be taken into account and the cutoff frequency has to be modified accordingly.